All right, conditional statements. So we use these in mathematics quite a bit. This is actually the most common type of statement that we're going to see. And they're always going to be in the form if P then Q. And our notation for that is P with that arrow there, and then Q, a single-lined arrow. So these are the most important thing to us, because that's pretty much how all of our theorems are going to be formed. And without them, we couldn't build mathematics. So sometimes these are going to seem kind of weird, they're going to seem counterintuitive, but the logic is going to be there. And so when we try to apply real life scenarios to the logic, we're not the most logical people, and I should say we're not the most logical beings, and so it can be kind of difficult to understand why something is true or why something is false. So the conditional, if P then Q, is false only when P is true and Q is false. Otherwise, it's true. Here's our truth table. We have P and Q, and then if P then Q. So here's every possibility of P and Q. And we said that it's only false when P is true, Q is false. Otherwise, it's true. So let's look at an example. And this is going to show exactly why it can be kind of weird sometimes. So determine if the statement is true or false. And we're going to be given two statements. Here's P, 3 is odd. Q, 5 is even. So we know in real life 3 is odd. And in real life 5 is not even. But that's okay. So if we look at the statement if P then Q, if 3 is odd, then 5 is even. If we look at if Q, then P, if 5 is even, then 3 is odd. So we want to know what is the truth value of if P then Q. If 3 is odd, then 5 is even. So P is true, Q is false, and so this is going to be false. But if we look at the next one, if Q then P, if 5 is even, then 3 is odd. Q is false, P is true. That's going to be a true statement according to our truth table. So we have a few different variations of the conditional. We have if P then Q, that is the conditional. And that P statement, the first one to the left of the arrow, is what we call the antecedent. To the right of the arrow is the consequent. And so I said a moment ago that P and Q aren't necessarily what we're looking for to determine the truth values of a statement, but they're just dummy variables, really. And so what that means is we could technically use anything at all. We could use if A then B, if M then N, if triangle then square. It doesn't really matter. What matters is what's on the left and what's on the right. Next we have a variation of the conditional. This is the converse. This is if Q then P. We have the contrapositive, if not Q, then not P. And lastly, the inverse, if not P, then not Q. And so we can end up showing, logically, using a truth table, that the conditional is logically equivalent to the contrapositive, and the converse is logically equivalent to the inverse. And that little symbol right there, the double-lined double arrow, is equivalent, logically equivalent. All right, so let's say we want to show that. We want to show the conditional is logically equivalent to the contrapositive. So first we're going to look at P and Q, and we know how to build that. And next we're going to need not P and not Q because they occur in the contrapositive. And so remember, those are just the opposite truth values of P and Q respectively. Now we'll look at if P then Q. So that's going to look the same as it did in the last table that we did. It's only false when P is true, Q is false. And this is where we need to be careful. If not Q, then not P. So the antecedent is not Q, the consequent is not P. So this is only going to be false when not Q is true and not P is false. So let's just look at an example. When we look at not Q true, not P false, we know that's got to be false. If we look at both of those being true, it's going to be true. Not Q false, not P true. That's got to be true. And lastly, when they're both false, we get a true. So there are a lot of different statements that we can show are logically equivalent using truth tables. We just have to show that their truth tables are the same.